the gas laws, the laws which are explaining the motion of these gas particles or relating the volume, temperature, and the pressure, like relating the motion, the temperature, and the pressure exerted by these gas molecule. So we have a Boyle's law, we have the Charles law, and we have the pressure law. But for all these laws, there is one parameter which is constant, because we are finding a relation between pressure, volume, and temperature. So all of them, we cannot discuss the effect of all three together. And so one of the parameters should be kept constant. So in a Boyle's law, we keep the temperature constant. For a fixed mass of the gas should also be constant. The Charles law, we are keeping the pressure constant, and the pressure law, we are keeping the volume constant. So according to Boyle's law, if the temperature is kept constant, the volume of a gas is inversely proportional to the pressure applied on the gas. If we apply greater pressure, the volume of the gas decrease. If we apply if we reduce the pressure, the volume of the gas will increase. And when two quantities are inversely proportional, the product will be constant. So PV is equals to K. As PV is equals to K, so if we have a container which is having initial pressure and volume, and we change the volume, we change the pressure, so the volume will also change. So here for the first container, P1 V1 is equals to K, and for second container, P2 V2 is also equals to K. So we can relate them by equation. We can say P1 V1 equals P2 V2, but this formula is only valid if the temperature is constant. For Charles' law, at constant pressure, the volume is directly proportional to temperature. Increase in temperature will increase the volume. Absolute, like temperature should be in Kelvin. So when two quantities are inversely proportional, their ratio is constant. Or we can say V1 over T1 equal V2 over T2. But the temperature should be in Kelvin when you substitute. For a pressure law, when volume is kept constant, increasing the pressure, increasing the temperature will increase the pressure exerted by the gas molecule. When two quantities are directly proportional, their ratio is constant. So we can say P1 T1 equal P2 T2. But these are valid only with limitation: temperature constant, pressure constant, and volume constant. But if pressure, volume, and temperature all changes, in that case we cannot use these laws. So we use a journal law, and using that journal law we derive an equation which is known as journal gas equation. So according to this journal gas equation, PV is equals to nRT, where P is the pressure, the SI unit of the pressure is Pascal or Newton per meter square. V is the volume. All should be in SI unit. So the SI unit of the volume is meter cube. So if it is given in decimeter cube, you should convert into meter cube. Pressure Pascal, where N is the number of the moles of the gas, denoted by, and the SI unit of mole, that is mole. What is R? R is known as journal gas constant. And what is T? T is a temperature. So we have PV is equals to nRT, which is known as a general gas equation. The value of the R will be 8.3 or 8.21. 31, you can use that. So if you have a container which is at initial volume V1, initial temperature T1, and initial pressure P1, and the volume changes, the pressure changes, and the temperature also changes. So this is P2, V2, and T2. So you have this, because here you will use a general gas equation. So we have PV is equals to nRT. So P1, V1, and T1, or I can say P1, V1 over T1 is equals to nR. N is the number of the moles. If the number of the gas particle does not change, so the moles will not change. So they will have the same number of moles. And the second one, PV is equals to nRT. So that is P2, V2, and T2. So P2, V2 divided by T2 is equals to nR. N is the number of moles and R is constant. So here nR is same for both. So what we can write a general equation as P1 V1 over T1 is equals to P2 P1 V1 over T1 equal P2 V2 over T2. So this is also a general gas equation because it is derived from a general gas equation where the number of the moles of a gas are constant and R is already a constant. That's called a general gas equation. Then there is also another equation which relate the number of the particles with pressure, volume, and temperature. So how we can use that? The equation which is relating number of the particles with pressure, volume, and temperature. So as we know, we have this equation PV is equals to nRT. That's a general gas equation where P is the pressure, V is the volume, N is the number of moles, R is a general gas constant, and T is a temperature. And what is N here? N is the number of moles, and the number of the moles is equals to number of the particles divided by Avogadro's number. That's in chemistry, you used to learn this formula that number of the moles is equals to number of the particles, number of atoms, molecules, particles divided by Avogadro's number. So number of the particles is denoted by capital N, and Avogadro's number is denoted by Na, which is 6 exponent or 6 point Avogadro's number, which is 6.02 into 10 to the power 23. So I'm just writing 6 exponent 23, which is the Avogadro's constant Na. So in place of this moles, I can write capital N over Na. So PV is equals to capital N, which is a number of the particle, and Na is the Avogadro's constant into RT. Now, if I rearrange this equation, I have PV is equals to N and R divided by Na. I just moved this is in whole as a denominator. So R divided by Na. And what is R divided by Na? R is a general gas constant and Na is a Avogadro's constant. So when general gas constant divided by Avogadro's constant, what we get? Like when I divide the two constant, I will get another constant which we call K, and that is known as the Boltzmann constant. So we have this Boltzmann constant. So what we can say, the formula which relate the number of the particle, so PV is equals to NKT. The number of the particles with pressure, volume and temperature. The pressure should be in Pascal, volume should be in meter cube. K is a Boltzmann constant and T is a absolute temperature. Is it clear, this part? So sometime we have the mixture of the gases at same temperature. Like example, I have a container. So if we have a mixture of the gases at the same temperature, like the temperature is 30 Kelvin. And here I have oxygen molecules, O2, which is 16 multiplied by 2, 32. And I have nitrogen molecule, which is 14 multiplied by 2, 28. I'll use another shade for nitrogen. First, I'm drawing these oxygen. These are the molecule, not the atom. Just representing the molecule. The reason why I do different size, just to distinguish that they have different masses. So we have oxygen, O2. And we have nitrogen, which is N2. So if they are at the same temperature, it means they will have the same kinetic energy. So if they have the same kinetic energy, as we know the kinetic temperature is same, so kinetic energy should be same. So kinetic energy is half mv square. And here V, which we'll substitute, which is a root mean squared speed. Now which molecule will move faster, oxygen or nitrogen? They will have different root mean speed. Why? Because we want this product to be same. The product of half mv square should be same with the product of half mv square of nitrogen. So the kinetic energy is same. As the kinetic energy is same, nitrogen N2, which is 14 multiplied by 2, that will make 28. So nitrogen molecules are lighter. So as the nitrogen molecules are lighter, to create a same kinetic energy, so they should move faster. And we have oxygen molecules. Oxygen molecules relatively heavier compared to nitrogen, so they should move with a slower speed. So lighter molecules will move faster and heavy molecules will move slower if we have the same temperature for both materials. Is it clear? Now some questions related to the topic. First, today we'll do MCQs, and the next session we will discuss the structure question. This is about the thermal physics. The graphs are there between the pressure, volume and volume temperature about the laws. I want everyone to go through those graphs as well, because if they're inversely proportional, it will be a curve, the product will be constant. And if they're directly proportional, then the ratio should be constant. This one is January 2015. Okay, we are discussing unit 5. Just a minute. So January 2015, according to old specification, Unit 5. So the first question is, okay, question 2. What could be the right answer? Question 2. So a student carry out an experiment to measure the specific heat capacity of a block of aluminum. Heating a block with electrical heater, the value obtained is less than the textbook value. So what could be the answer? The value obtained is less than. Look, for example, if thermal energy, the formula for specific heat is equals to energy divided by mass into change in temperature. So for finding a, if I supply heat energy, the most likely reason for this, the heater is inefficient. Look, if heater is inefficient, you will use a heater for a longer period of a time. If you use a heater for a longer period of a time, it means you will supply more energy. If you supply more energy, so you should get the higher value of specific heat capacity. So heater was inefficient, will make higher value of specific heat. The thermometer scale did not start from 0. This will not have any effect because that's depending on the temperature. The thermal energy was transferred to the surrounding. If thermal energy transferred to the surrounding, so because if you are supplying heat energy to a block by the heater, if the thermal energy transferred to the surrounding and thermal energy absorbed by the block, so what happened? It will show us, because if thermal energy supplied, it will show a small loss to the surrounding, so it will show a smaller change in temperature. As it shows smaller change in temperature, specific heat will be higher. But if mass is overestimated, like if you record or if you measure greater mass, it means the specific heat capacity will be smaller. That's why B is the right answer. So A is not correct, C is not correct, D is not correct, B is the right answer. Is it clear why? A pan containing a water at 300 Kelvin, the water temperature increased to 330 Kelvin. Assume that the pan behave like a black bar. This is related to the cosmology. So we will skip this part. That's related to cosmology. Because of temperature, I thought it was thermal physics. So only one question was there related to thermal physics. Another paper, June 15. In question 9, which graph shows how the pressure vary with the volume for a fixed mass at constant temperature? Basically, which one is the correct graph for the Boyle's law? Keep in mind, pressure and volume are inversely proportional. What's the right answer? If two quantities are inversely proportional, it should be a curve. If one increasing, other decrease, the product should be constant. So, yeah, that's right. B is the correct answer. Because why? Even though C is also the same thing, but for C, it means, if, for example, if we have pressure, so it means when volume is zero, the pressure was maximum. But that's wrong. Like if nothing is there, how it will exert pressure? That's why C is not the right answer. B was the right answer. So only this question was there. Not too many MCQs, but structured questions. You will find more structured questions rather than MCQs. January 2016, Unit 5. Okay. Question 5. Energy supplied to a fixed mass of a gas in a container and the mean square speed of a gas molecule is double. The absolute temperature of a gas will increase by what factor? See, the energy supply, the mass is fixed and the mean square speed, not the root. Read the mean square speed. They did not use the term root. Look, when we say, we are saying kinetic energy is proportional to temperature. So half mv square is proportional to K, the temperature. And what is V here? V is VR, root mean square speed. But what they said mean square speed is double. So this is this whole factor without taking a root. So if this is double, what will happen to the temperature? That will also double. You got my point? Because the mean square speed means this whole factor. It's not, they did not say root mean square speed. If they say root mean square speed, it means only this part is changed. And if this part is double, then the temperature will increase by 4. But what happened? Only the mean square speed is double. So if mean square speed is double, which is V square, without taking a root. So the kinetic energy will also be doubled. How you relate the VRMS? So when we take a root mean square speed, so what we do a square, then we take an average, and then we take a root. And how we represent this? We represent by V bar. The root means square speed. Question 8. A piece of chocolate is heated at a constant rate. Means same rate it is heated, or same amount of energy supplied or removed per second. The graph shows how the temperature of a chocolate vary with time. Select the correct statement for a time between x and y. Which one is the correct statement for a time between x and y? Question 8. Yeah, A is the right answer. Why not? Look, internal energy is a sum of kinetic plus potential. Okay. So basically, when we supply energy to change the state, the temperature does not change. So the kinetic energy will remain constant, but the energy supplied is used to separate the particles. So the potential energy is increasing. If the potential energy increase, the total energy, which is a sum of kinetic and potential, will also increase, even though the kinetic is kept constant. The temperature is not. So internal energy of a chocolate stays constant. That's wrong. The kinetic energy of a molecule in the chocolate is increasing. That's wrong, because the temperature is constant. The potential energy between the molecule is constant. That's wrong. The potential energy is increasing. That's why kinetic remains same, potential increase. So sum of kinetic plus potential changes. So internal energy change. Then this is about the simple harmonic. Another question, June 2016. So this one is June 2016, Unit 5. Question 6. A mixture of hydrogen and nitrogen is used to inflate a balloon. On average, the nitrogen molecule in the mixture. Question 6. What could be the answer? So D is the right answer. They have greater momentum as because nitrogen, the issue is in the question they did not mention anything about relating a temperature. So are traveling at the same speed as hydrogen. So when they're in the same balloon, they cannot travel with the same speed if the temperature is same, because the kinetic energy is same. So one which is lighter will move faster. Are traveling faster than hydrogen. So this statement is also wrong. Have the same momentum. They cannot have the same momentum. Why they cannot have the same momentum? Momentum is a product of mass and velocity. Kinetic energy will be same, but the momentums will be different. The kinetic energy is equals, as we know the formula, the kinetic energy, which is half mv square, is equals to under root 2 mp. So they have a greater momentum as compared to the hydrogen molecule. So only statement which is true is D. Is it clear? So these are the MCQs related to topic thermal physics. Next session we will discuss more MCQs and structure questions. Any question, any doubt related to the class today? So I'll end this session and share this recording with you.